Hi, everyone. So I would like to introduce you to Marjorie Chan.
Hi, Margie.
I don't know if
Hello.
probably she doesn't see you. No, she doesn't see you, but we have shown her the, yeah, we welcoming you and you've seen the space. Can you hear me or not? Yeah. So I will just, so the reason for which Margie is in the screen and I'm here is because she lives in Salt Lake City. And with the current situation, it's a bit complicated now to travel. So we decide to have this setup in which she can also be part of this. For me, it's very important. So we collaborated in this project, which we will both unfold from different perspectives. So Marjorie is an associate professor in the Department of Geology and Geophysics in the University of Utah. I'm going to read a little bit your bio, Margie, if it's okay.
Okay.
So over her career of 3 decades at the University of Utah, Chan had an active research program spanning some of Earth's oldest sedimentary rocks to some of its youngest Pleistocene rocks. Her recent research had applied terrestrial geology examples to better understand Martian geology. She had published 117 peer-reviewed publications and had been featured in National Geographic and Discovery Channel documentary films. Recently, she was the 2014 Geological Society of America Distinguished International Lecturer, where she gave 53 lectures in 6 countries spanning India, New Zealand, Australia, China, Japan, and South Korea. Dr. Chan was department chair for 7 years at the university. During this time, she oversaw all departmental programming for new construction of the LEED certified award-winning geology and geophysics building with educational high impact visual displays. I just want to say I have seen the building and it's truly amazing. I will give the space to Margie to talk. Afterwards, I will explain my part of the project. So Margie, as I said, is a geologist. She took me to higher, louder? Uy, we lost her. Dios mío.
I'm still here.
You're still there. I just lost
Yeah.
there. Okay. So Margie took me to the site in which I developed the project. And well, we'll explain. She'll explain the geology of it and maybe other things she wants to share with us about the process. And then I will explain my part on it. And then if you have questions, we are both around. So Margie, if you want to start.
Okay, let's see. Can you see my screen?
Yeah, we do.
Okay.
We do.
So you can see the full screen, right?
Yeah.
Okay.
Full screen.
So I'll just briefly talk about concretions and the idea of what the science is behind this, and telling you a little bit about the applications from Earth, which is shown on the left, to Mars, shown on the right. Let's see. So this will contain 3 different parts. I'll first tell you what concretions are. And then secondly, I'll discuss why they're important. And then the third aspect is how this connects to art. So what concretions are cemented mineral masses in sedimentary or layered rocks. And oftentimes the rocks that we see around us are sedimentary. They make up about 70% of all the rocks that are exposed. And through Earth's history, different waters actually seep through the rocks and they deposit cements. And the cements make things hard. So you can see examples of a concretion right here in shale and concretions here in sandstone. And if you could look in a thin section under the microscope, you would see the different sand grains shown by the light colors. And you could see that the holes or the porosity that's still remaining are shown by the blue, but the concretion is much different in that it's been cemented. So this part is very hard versus this part, which would be a little bit softer. A host rock would be a little softer. So concretions can form in all kinds of shapes. You can see things that look like blocks or crinkly layers, things that look like pipes, or you can see some of these beautiful sculptural masses. But although people have considered concretions to be oddities, things that are difficult to explain, the sphere is the most common shape. So as waters actually seep through the rock, the sphere, this round shape, takes the least amount of energy to form. And that's why those are the most common. You can see that concretions can form all kinds of sculptural shapes. This one is quite large. This is from France. And I just want to emphasize that some concretions are very valuable. So some of these sculptural pieces from nature might actually be tens of thousands of dollars. The concretions can form in many sizes, things that are as small as sand grains, up to things that look like golf balls shown here, to one that my son is standing on, to some of these very famous Meraki boulders in New Zealand. And then this is another picture of me that I just took last week, that we took last week while I was in Oregon on the coast. So concretions are fairly common in the geologic record, but some of the examples that Irene is going to be talking about are the ones that are particularly unique and applicable to understanding Mars. So we also know that concretions can have a variety of different cements or different compositions. Sometimes they'll look white where they're or a light color where there's carbonate cement. We can have some that are iron pyrite. We can even have some that are blue, which are the mineral azurite, green malachite. But the ones we're going to focus on are these ones that we call iron oxides. And these are the minerals hematite and goethite. Internally, the structure of the concretions can be solid, but oftentimes they show a concentric rind. You know, this might look like an orange, or it might look like different layers in an onion, that type of thing. And you can even see how the different layers kind of weather out and give you an idea of what the structure is. So we are going to focus on some of these iron examples that have these kinds of mineralogies of iron and oxygen. So the cement makes these forms more resistant to weathering. It makes them harder. And so the rock, or the host rock, often weathers or erodes away, and you're left with these, which are really the records of the fluids that actually cemented the rock together. They can be these round forms, or here's some spectacular examples of these very elongate forms. Now, the reason why concretions are important is that they leave behind a record, and this record is either in these marbles, these things that we call concretions, and these are the evidence of water that's been underground that was seeping through the deposits, the sediments, or the rock. So we're focusing on the iron oxides, and in Utah, we're very fortunate to have many national parks, and part of the reason that they are so impressive is that we have these layers. And these layers, you can just think about just like layers in a cake. They're stacked on top of each other. And of all the layers, one that's quite thick is called the Jurassic Navajo sandstone. So Jurassic would have been like at the time of the dinosaurs, 180 or so million years ago. And of all the units that are on the Colorado Plateau, kind of this area of southern Utah, this is the unit that was the most porous, or had the most holes in it, so that waters could seep through most easily in this particular layer. And so this is a layer that has these great examples of concretions. Now, the concretions, these hard cemented masses, are also connected to some of the colors that you see in southern Utah. You can see that Mother Nature's palette is essentially using iron as the pigment that's really making up so much of the color that we see in these sedimentary units. You can see red colors to white colors to yellow colors. And then, this picture that I used as my Zoom background, these are just really spectacular colors for Mother Nature to put together. And these different colors are telling us where fluids have been. So these colors, as well as the concretions, are telling us the story of past fluids. This might be a little bit complicated, but if you can think about the painting or the coloration of the sandstone going through different stages, initially, fairly early on, we might put the red down first. Mother Nature might do this, where if you could look at the sand grains, they would have these very thin films of the iron oxide around them that give it that red color. And then when these sediments are buried and they're underground, you have waters that actually come through, they seep through, and they bleach the sandstone white. So there's a chemical reaction that actually kind of dissolves the iron. And then those waters have more iron in them. And later on, they meet with other types of waters or different kinds of chemical conditions. And it causes the iron to reprecipitate in these kinds of discrete balls or these marbles. So the iron goes from being distributed very broadly like this over here on the left to being very concentrated and compact like this over here on the right. And you might wonder what fluids are responsible for doing that. And you can have all different kinds of chemical fluids like petroleum or some methane or CO2 rich fluids or even organic acids that are capable of chemically doing this bleaching. And so in some places, you can see the sandstones are very white, and those are places where some of the reducing fluids in particular have removed a lot of the iron. Sometimes you can actually see some of these hydrocarbons actually dripping out of the rock. So to try to show you how this works, there's a little movie here. You start off with red deposits, and then you have these reducing waters that come through and bleach the sandstone white. They remove the iron and put it into solution so that these waters are very saturated with iron. And then you might have the mixing of a more oxygenated fluid, and then that causes the reprecipitation of the iron into these organized balls that are often kind of spaced out with each other. So this is a chemical reaction front and represents some of the history of the different fluids. Let me try to go forward. So, what does this have to do with Mars? Well, some of the rovers were sent to different places to look for evidence of water. And we know that the mineral hematite, one of these iron oxides, is particularly good at being deposited in the presence of water. So the Mars rover Opportunity landed in this area of Meridiana Planum, and it took its first picture here, some of its first pictures in this area of a small crater. And you can see that here we have the iron distribution kind of in an image that shows from the colors where it's the most concentrated. So red is the highest amounts of iron. And then here we have lower amounts of iron where it's white, and then intermediate amounts of iron where it's these greenish and blue colors. And these blue places are where the rover actually bounced. This is similar to some of our outcrops in Utah. You can see that here where it's red and you have all these concretions, this would be high amounts of iron, similar to this red coloration that's been superimposed here. And then the lesser amounts of iron where it's white would be analogous to this here. So what was important is that when the rover took very close-up pictures of the rock, they could see things that would look like this if you could see it with your naked eye. There were these round forms that look kind of like blueberries. They would be a steel blue kind of color. And this has false colors superimposed on this rock picture, just to kind of emphasize where the spherules, these hematite masses would be. And you can see that they make up these balls that have this yellow color superimposed on it. And they're distributed in this rock, kind of like blueberries in a muffin. And so they gave these spherules the nickname blueberries. And then as the science has progressed, we've interpreted these as concretions. And you can see the similarities of these Utah examples where they're resistant to weathering and form these accumulations. And in the outcrop, how they're physically distributed so that they're not really always touching. They're more like the idea of blueberries in a muffin. So what's important is that we can use these concretions to tell us stories about water. And you can see some of the examples here from Utah and how they compare to some of these black and white images from Mars. We have many more shapes on Earth, and maybe that's because we've had a longer history of water, but you can see that even on Mars, you have these very small forms. They're about the size of 4 millimeters, and oftentimes they make doublets and triplets, as you can see here, similar to some of the ones that we have here on Earth. So on Earth, concretions have to be taken into the context that on Earth we have so much life. And probably for the last 3 billion years, excuse me, of our history, really a long time of our history, our waters have been contaminated by microbes. Literally all the waters on Earth have life in them. So what we know is that on Earth, sometimes the timing of the concretions can be fast. So here's a pocket knife that might only be 100 years old, and we know that the concretion formed around the iron in the knife blade. So this shows that concretions can form fast, and probably microbes might be concentrated in areas where we have these chemical gradients, these differences of the chemistry in the waters. And so these are places that we might actually explore for life, where we know that there's chemical reaction fronts and maybe where we have some of these concretions. So the concretions are really important to the idea of the possibility of exploring for life on other planets. So how does this connect? How do these concretions connect science and art? Well, one of the things that we're doing is sharing stories. And for me, Irene has been an artist with a lot of vision to do something very different in a way that tells the story about the science as well as the beauty of these deposits. So with Irene's vision, her drive and dedication under very hot conditions and hiking in sometimes several miles, several kilometers, I guess there in Europe, she's had remarkable patience to put together an installation that really can tell you a story about these unique features of nature. So she's seeing the landscape with different eyes. She's actually taken some of these very natural accumulations and been able to reproduce them so that you can physically see them and be closer to them, even though you might be thousands or tens of thousands of miles away. So I'm excited to hear the story that is shared in a thoughtful and inspiring way. And I'll conclude by saying just 3 points. First of all, colors and the concretions that you can see up here are really important records of past fluids. And so we use these as proxies to really tell us more about the history of water. We can take these particular examples and apply them from Earth to Mars. And in both cases of Earth and Mars, it's really helping us explore the idea of how life might be influential in these concretions and how they might record the possibility of microbial life. And then third, art. I'm excited about art because it really captures creativity, imagination, and it really helps us visualize more of our science. And this is important to sharing the stories. So that's what I wanted to say, and I'll stop sharing, and thank you very much for your attention.
Thanks so much, Margie. So what I will do is to share a little bit the backstage of the making of the piece, and then you probably can ask us both probably very different questions. And thanks so much, Margie, again, not for everything, and also for this presentation.
Sure.
Yeah, one of the, so Margie, besides being a geologist and everything else, she's also very interested in art and crafts. And so it was kind of a natural, I gravitated towards her also quite organically, not only through the science, but also through the understanding of the science and everything else. So I'm going to share my screen. And make it bigger. Cool. I don't hear myself, so I don't know if I'm shouting or I'm low. Louder? I feel I'm really screaming. Sorry, Margie, I'm going to really scream. So louder, louder. Well, you just make signs if you stop listening to me. So, but would she hear me?
Don't worry about me. Do what's best for everybody.
Okay. Can you hear me now or not? You can hear me?
Mm-hmm.
Okay, cool. That's better. I can control my, I know what I'm doing. So, well, as Margie already showed, this is the landscape. And I mentioned briefly, I did a couple of field trips. So first I got in touch with Margie because actually I was interested in something a little bit different, which was this landscape very close to this area, which is called the Wave, which is a very painterly landscape. So that's how I got in touch with Margie. And then we were discussing it and this and that. And then she said, I'm actually doing a field trip. I'm going to discuss with some colleagues something else, and maybe you want to come. So somehow I managed to get that organized, and I did one field trip. With them, where they were actually discussing, probably Margie can explain it later again better, but they were discussing these concretions, where they were positioned, the composition of it, actually, well, different things. So Margie was actually reviewing a paper of them. So we made a round. I was just listening, taking notes. Then we stayed a few days, made several walks, and then she showed me, or we probably found out together this location, which was quite amazing. And so you find this, so the history of so as an artist, basically I need a number of different things to be, say, inspired to do something. The story is very important. So the story of these concretions was amazing, and they're very relevant for all what Margie had explained. And the shapes are fascinating also. And the way they get distributed, the way they're all different from each other. The way you look in one direction and you see one composition, you look in the next direction, it's completely another composition. The way they find a place in the landscape, creating different clusters. So in terms of potential for drawing or sculpture, it's very, very appealing. So I decided to try to come back there, which is again not so easy because it's a desert. There are certain seasons where you can work, certain seasons where you cannot work. Also, you have to find funding for everything, as everyone can imagine. Margie also helped me finding a field assistant. You also cannot be alone in those kind of areas. I'm not very good with directions, so I need someone who can also guide a little bit, and I need a lot of time for my work. So I managed to set up the conditions for myself and field assistant, she's called Corey Dintel. She also created the map that you saw in the back of the room. And so we had like 10, 12 days to be together in that place. We stay in a small town, and then we walk every day. It's about, I don't know, 3-4 hours walk. It's very, very hot. So we started walking every day at night. So when the sun came up out, we were already working, and we could work from say 6 to 11, and then we have to kind of really go down because it was, I mean, you would get sick basically working there longer. So I was doing this series of drawings, looking at different corners of the landscape. So that was part of the process. I did about, I think, 10 drawings of them. So I was basically looking at different spots, finding it, framing in my head, and doing a drawing a day. In the meantime, Corey we decided to create a grid in the landscape. and to take measurements. I wasn't sure if I was able to do the piece that now you see there, but because getting there is so complicated, we decided to anyway try it. So, and Corey is trained in paleontology. She's also a photographer, very connected to art and very sensitive to art, but she's trained as a paleontologist. So she has a very practical way of unfolding like the techniques and the systems for something like this, because it's actually quite complicated. So I wanted the measurements of all the balls, and we also needed the distance in between the little balls, and with the distance from the grid to each of them. So all that had to be measured. So while I was making the drawings, Corey was creating those maps. So we put the grid with a string on the landscape. We put a little piece of tape, a number in each of the balls, and then each of them, she took 3 measurements. Then she also took notes concerning if the pieces were smooth or if they were bumpy, because the textures are quite different. Also, sometimes they are spherical, sometimes they are oval, sometimes they're full, sometimes they are a bit broken. How much is broken? 180%, 50%. So all those notes were taken. That's her suffering. So it was quite a challenge physically to do that. After we came back, she turned all that into these maps. So this is just one page, but we have like 50 pages. So there are 500 something balls. So we had to transform all that into measurements that are readable and shareable with me and with the technician. That's the map you see on the back. And then it starts a full different process, which is working with the ceramics. So what you see in the room are ceramic pieces. That needs a lot of research also in which clay. So I wanted to create a variation. So which clay, which color clay, shyness, oven temperatures. So all that's also behind. Then it goes into another crazy. So the ceramics have to see how much these measurements will give in weight. So you can have to cut the piece of clay that is the right weight. And then we have the measurements so that each little piece is individually crafted. How to give textures to these little balls. Then you need to number them. So they have to go, you have to know which one you are doing with the number, but then they go to the kiln. So you cannot lose that. So they have to be positioned in the ceramic when they're raw with the numbers, and they have to go in the kiln. Everything has to be very systematic. After which, each of them have to be numbered after the oven as well, because we need to install them again here. This is the workshop. This ceramics. I work with him since many, many years. He used to be the head of the ceramic department in the Rijksacademie. Peter Kemming is his name. When I did the Rijksacademie many years ago. And then he left the academy and I kept working with him forever. He has a beautiful workshop in France. So this is the workshop. So it was quite a procedure. And then after the pieces were baked, let's say, we wrote the number in each of them. And then we created a system to be able to install it here. So the same map has cut out the shapes. And we knew which number was there. We put pieces of tape with the numbers and then remove the map. And this is a beautiful picture that Michelle took. I really like it. So then we remove the map and we position every little piece of clay. So that's what's in the story of the making, which I think is interesting to show because, well, the work looks actually quite minimal and quite clean, but there is a whole trajectory which is connected to the field work, to the stories, and also to the making, which for me is also very relevant. So I'm going to stop sharing screen, and if you have questions for us, we are happy to answer, I think. You still there, Margie?
Mm-hmm. Yep.
This is stop. Okay. So now you see. Marjorie again. If you have questions for her, I will, probably she won't hear you and I'll repeat them.
I just wonder, what's the relationship between making the drawings of the landscape and the sort of more scientific measurements that your assistant was doing on the space? Because I would imagine when you're drawing, you're sort of choosing a composition or investigating the landscape. But because you had to do both of those things at once, so your assistant is actually already doing the measuring while you're drawing. It's not that you've used the drawing to figure out what place to choose. So what's the relationship between the landscape drawings and the actual measuring that's taking place?
Did you hear that?
I think so. What was the question is, what's the relationship between the actual measurements that you were doing
Yeah, and the drawing.
and the drawings?
Yeah, so it's a parallel, as you sense. So basically, the location we map is only one. So during the 10 days I was drawing, it took all that time to make the measurements. So basically, I decide the location with the same eye. I decide my drawings, let's say, and then yeah, we kind of work in parallel. But they are parallel tracks. They are not literally connected to each other. I mean, it's the same way I would decide what to draw. I would decide what to recreate in this.
And are you basing that on the way it looks? Like you said, inside, it's not because it's a beautiful landscape, it's more to show the process. How do you choose what to draw?
I think it's very interesting because the concretions take the shape of what's underneath the landscape. So it is actually has to do with the way they organize themselves. Their clusters, empty spaces. So it is composition. I'm trained as a drawing, actually in classical drawing. So I do look at things with that in mind. Yeah. Another question?
Yeah, I don't know if you have already decided to, but so it's the first time that you are exposing this, or with this plan, are you going to bring it to other museums, to universities? I'm imagining it would also be a nice opportunity to show it to other people without having to bring them to their circuit. So where do you want to go with this?
You hear that, Margie? But not.
I couldn't quite hear that one.
No, because that's far. She's asking what's the plan with the piece for later, for future. If I'm going to show them later. So actually, I don't know yet. I would like to. I really would like to. And actually, I thought it really worked to show the map and the sculpture because also the configuration of space. I thought that link was interesting, but eventually I would like to show them with the drawings as well. And I also did some drawings of the close-ups of some of the pieces, which are also quite. I like them because the light is very strong in the space, so the individual drawings I also quite like. So I would like to show them, of course, a lot more. You like them? Thanks. Yeah, I mean, hopefully, it's not so easy to find venues and all that. So the plan is to try to show them, and I would love to show them in the region also. No?
Maybe I could also say that I would like to actually see more of this shared as well, because in so much of our science, when we try to share our information, it's kind of two-dimensional. But I think if people could actually see your installation, even the three-dimensionality of the physical objects kind of helps people understand it more. And I think this is also demonstrating the relationship between science and art and how we can partner to actually try to help understand some of these things. And so when somebody asked before, why do you pick a particular area? It appeals to you visually, but also what you've done is take some physical measurements that was very painstaking and very time consuming. So we could actually take that data and look at it as a representative population. What is that representative area actually like for telling the story of more of a larger area where we haven't really taken the time? You can't do all those measurements for everything, but the fact that you have some detailed measurements for a small area can actually be a good representation of what you might be able to generalize for a larger area.
Might disappear because people get too much interested in this phenomena. So that would also be like thinking about showing this piece in the region itself.
Yeah, I was
where
telling
people
them,
belong.
Maria was telling them the story of the truck that came and saw all of those.
I'm sorry, I couldn't hear.
No, I told them before we started the conversation that story of that truck that came to Escalante and took all those concretions. So they're asking, can you hear me?
I can just barely hear you. Maybe could you?
Yeah. Is it better? Is it better?
Yeah, that's better.
Okay, so no, I told them the story about that truck that came to the monument and took all the concretions away.
Yes.
So they're
yes.
asking if there is a danger in making this work more visible in that regard, that people know more about it.
Yeah, there always is a danger. You know, that the more people that know about the area, the more use and impact there can be. But at the same time, there's also more learning. And so, you know, in some ways, the learning, I think, will outweigh the damage, and that people that see it will appreciate it more and will take more active steps to conserve and preserve those features, because they recognize how beautiful and unique it is.
Yeah, I can only agree with that. I think education, I mean, and information and education only can help. I mean, if we have some hope in all this, it's by creating a consciousness, no? Us? Or? Yeah. So they're asking if I relate to the pieces as replicas or as my own creations. So I would say like both. So for me, it's there are steps where so it's a reconstruction of the space in measurements, etc., etc. But I also see there are filters that have to do with my own hand and my own selection of materials. So it's not one-to-one really. And I did try to give quality to each of them. So kind of look at them, getting the textures were also interesting. So we were trying different things, like pressing them into rocks, for example. So that's very sculpture as a process. And for me, it's important to keep that also alive, because at the end of the day, you want a sculpture that has qualities. So for me, it's important to keep into the process those aspects of my work.
Carrying out an entire project so far, and preparation is a part of the project. But when did you get the feeling, hey, now something has changed, and now I'm really involved in the actual work I was planning to do? Is there some moment
Shift.
that you recall that was the moment that this is really well where I have been preparing for?
Okay, so he's asking if there is a moment in which I realized something switched, that I realized now the project, all my preparations are really the project. So I would say, so I don't know what to do with this. So I would say it's, so from the beginning I knew what I wanted. So I always thought so let's say the first field trip was very tentative, but I already knew what I wanted. And then the rest is just trying to get there because it's a lot of logistics, fundraising. Then I came back with the measurements. I still had to fundraise for the piece. The ceramic piece is also another round of trying to make things possible. So I think from the beginning I knew, and then the rest is just trying to follow the steps to make it possible. And sometimes you can manage and sometimes you cannot. But one thing, I had quite a clear idea quite quick. So we visited that site with Margie the first trip, and I knew I wanted to come back there. I knew there was potential in those forms for a sculptural piece. But then if it's possible or not, it has to be seen because it's so complicated. Yeah, and it's always like this with my work. So I have ideas and then I slowly work my way through. It took us I think 2 years, if not 3. I think since the first stream, maybe 3.
Yeah.
Yeah.
I have a question about the fact that you collect the data and also collect the precise form of the object, but you left out the surface of the landscape because they also differ in height.
Yeah.
So you have 2-dimensional mapping, but not exactly the height of the object, which when I see pictures, it's very clear that they follow certain slopes of this landscape to form these clusters and to where there's space. But when you leave it out, it's like, yeah, you're missing maybe some data to interpret the exact work in a way. So the choice, that's of course a conscious choice. I want to know more about that aspect.
Yeah, so she's asking, because I removed the landscape in a way, the surface where the rocks are, the concretions are set. So she's sensing that I remove the different heights, the levels, basically why things are in that form. So she's asking me to explain why. So basically, so for me, it's not a, so I work in as a, my work is really informed about minimal art. So my work is really about removing elements. So you would, and it's a form of representation, but it's not, I don't work in figuration. So for me, it's not interesting to do a diorama of the landscape. So what you're sensing that the pieces take a certain shape, it is there because that's why those things have that form. I mean, they have those clusters because of those reasons. And they have empty spaces probably because it was a slope and they couldn't hold themselves there. So it's implicated. So it's somewhere it's in the shape. So that's why those things have that configuration. But I'm not interested in creating a diorama so it's not didactic in that sense. For me, it's very important not to be didactic. So my collaboration with the scientists, and in most cases, and with Margie too, is because there are other elements that have to do with the visual qualities, with creating space in people's head that are not necessarily representation. So it's in purpose.
The objects themselves are very precisely.
Just about. I mean, there is also, it's connected to what you were asking. There's also sculptural pieces. So I work on the textures. I work on the qualities of the clay. I work on them as sculptures. So otherwise you could recreate a 3D thing with a laser, which I'm completely against. So for me, the making, it's important. So there is a relationship with the making that has to do with the visual and tactile qualities of things.
I have one more question about whether the concretions are, they didn't roll there, or how long have they been in that pattern? Is that something, do they grow there? Is that where they originally come into being? Or are they somehow moved there by wind or by the water?
That's a question for you, Margie, I think. Can you hear it?
Could you repeat it?
I wonder how the concretions got there, if they've rolled there, or if the pattern is actually the original location in which they were formed. Like how long have they been in that pattern?
So she's wondering how they got there in that shape, if they roll or if they got exposed.
So the concretions form, in the rock, and they'll form that round shape initially. And maybe you can think about, there's kind of a children's game that's called musical chairs. And there might be like one chair in the middle. And then if you think of the people as being the iron, they kind of circle around the chair. And if there aren't as many people, then they're closer to the chair. If there's a lot of people, they're farther away from the chair. And so that sphere is the easiest shape in nature. That's kind of the natural shape. And if you had a lot of chairs spread out in a room with people circling around all the chairs, you would see that there's some kind of a spacing that's just kind of natural. When the rock is around the concretion is softer, it erodes. And so eventually the concretions will pop out. And then, as you say, they will roll down the hill, or they will accumulate typically in some of these low areas. And that's just the process of nature that has to do with the amount of erosion and the pathway of water actually helping collect some of the concretions over time. Does that explain it?
Yeah, it did.
I have a question for you. How did you decide which kind of clay to use for the?
She's asking me how I decide which kind of clay. So it's mainly connected to the color. So I was trying to get variations in darkness and shyness. So yeah, different. We were exploring that, but we did a lot of experiments before deciding. No, it's not the part of the floor. No, it's actually not clay, the original. The concretions are not clay, the real ones.
No, of course, yeah, but.
No.
For the question, the concretions that you can find in the deep sea or in other places, are they similar? Or?
She's asking if the concretions you can find in the sea are similar.
In the ocean?
In the
Is that
ocean.
what? There are some things that are similar that are manganese nodules, and the manganese nodules are dark colored and they're similar. They're not quite as perfectly spherical as the concretions tend to be. And so they're a slightly different process and a slightly different chemistry. But they're similar in that they're concentration of certain elements. And it's all done, by nature, but by different types of processes.
Thank you.
These are really the only place where the process is exactly the same as on Mars.
She's asking if this is the only place where the process is exactly the same as in Mars.
Well, the process, how do we explain this? There are concretions that form in many different places, and there are multiple types of compositions. But I think what I would say is that this place in Utah is a place where they are the most abundant, where there is the most variety, where they are the best exposed, and it's the right chemistry, the right elements of the iron being very dominant. And so all of those things put together meant that this was the area that I proposed as an analog to Mars. And everybody has kind of focused on this just because it's an easy example to use to try to understand and interpret the geology of Mars. But even on Mars, on this other planet, we've started to see that there are multiple types, multiple sizes, maybe some variations in the chemistry, and maybe different locations. Like there are at least 2 different locations now on Mars where they found these. So it is important to recognize that the variability of the concretions actually helps us understand more about what kinds of processes might be involved, and what happens if you tweak one process, what happens if you add more iron, or what happens if you have water over a longer period of time. Does that make them grow larger? So all of those things are important to the story and making the comparisons for these analogs that we want to interpret on Mars. Even on Earth, it's hard to know how microbes might be preserved in these concretions. And that's something that I think will be continuing studies in the future. And I'm sure that people will look at these examples from the Navajo sandstone of Utah, just because they're some of the best examples anywhere in the world. Does that answer the question?
Yes, thank you.
I have one other question. If
Sure.
So this process is still continuing, I guess. I mean, did it stop, or is there a danger maybe when climate change is progressing? Is this also influencing the formation of the chemistry of the stones?
So she's asking if the process of the creation of the concretions is still ongoing, or it's something that is stopped, and if it's affected by climate change.
Yeah, that's a good question. The formation of the concretions, I think, is essentially stopped. You know, we don't have the same waters moving through, and when the waters initially moved through, these rocks or these deposits were under the ground, but since then they've all been brought up to the surface, and so essentially that stops the process. But there is this continuing erosion and weathering that's going on, and you know, it is interesting to think about what is the possibility of climate change and how does that affect things. It will probably increase the weathering in some areas. Maybe it makes more of this area or an extended area more of a desert because it's hotter and warmer. It's kind of hard to know, but the concretions themselves really captured kind of a moment in time, and they are not really being added to anymore. They're just being exposed and brought to the surface or accumulating in different places.
Some more questions? Cool. I think we are finished for today.
Is your engagement with these marbles in this place?
In this place, in this park?
Yeah. You see this like as a kind of final piece that you want to make there, and you're involved there? Or do you feel like this is a place you can come back to?
In Salt Lake, you mean? In this particular location in Escalante? She's asking if I see myself continuing with the project, or if I think it's finished. No, I think there are a lot of things that I could do. What Margie was saying with life, the way the life affect the rocks and all that, the microbes and all that. There were a lot of very beautiful patterns in there that stay in my head. And yeah, I think there are other things I would like to work in the region. So yeah, if possible, and now that I see the pictures again and I talk to Margie again, even more so. Yeah. Cool. Thanks so much to everyone. And thanks, Margie.
Thanks for letting me participate.
Thanks. We're very happy you participate, even if it's in this strange form.